Teacher spends exactly £3.92 on some fruits, choosing from apples costing 20p each and pears costing 28p each. How many of each type of fruit might she have bought? So first of all, I'm going to change this £3.92 to 392 pence and then just work in pence throughout. And then I'm going to, well, one apple costs 20p, so two would cost 2 times 20, three would cost 3 times 20, and 8 apples would cost a times 20, or 20a. So I'm going to let a equal the number of apples. And then p is going to be the number of pears. Because then it's going to cost 28p, where p is now the number of pears, all right? Not p, as in pence. And that is going to equal 392. And what I've actually constructed is a Diophantine equation. Look him up, what a legend. He and of course many people after were interested in integer solutions to equations. Like this actually has an infinite number of solutions for so like you can let a equal 1, you get the value of p and so on. But if there are restrictions, such as a and p being integers, or in this case they have to be positive or 0, actually just the counting numbers and 0, then we can find solutions. So really nice topic in maths. And what we should do is first of all just try and simplify it as much as possible. Now 4 goes into each of these, so I'm going to divide through by 4. 5a plus 7p is going to be, 4 times 100 is 400, so I just need to subtract 2, it's going to be 98. Now there's another little trick you could do with Diophantine equations, well worth doing, because at the moment there's going to be quite a wide search for a and p. If there's a common multiple at all, like if any of them share a multiple, then we can actually divide through by that. So 98 is not a multiple of 5, but it is a multiple of 7. So we're now going to divide through by 7. If you don't do this, you're just going to have a longer search, basically. 5 over 7a plus p. Okay, and how many 7s go into 98? 1, 4, 14. Okay, so a must be a multiple of 7. Because if it's not, then this will be a fraction, and p, remember, p is an integer, so that it's not possible, because, yeah, you won't, well, actually, you'd get p as being not an integer, which is not possible. So I hope I've justified that. P has to be a multiple of 7, because then it's gonna cancel out with that 7 there. So now we can just try different multiples of 7 and see if we can get there. So let's go with a and p. Right, and actually, you've got to be a bit careful because it doesn't say that we're choosing. This is a key thing. We're choosing from apples and pears, but we could actually not buy any apples. So the first result is going to be that we buy 0 apples, and therefore we're going to buy 14 pears. That will work. Then next, it's going to be 7 apples, and then we're going to get 5 here as a result. So P will equal 9. And then 14, which will give 10 here, and therefore P will equal 4. And then if I go with 21, well, I'm going to get 15. I'm going to get a negative solution, so I can reject all solutions onwards for higher A, P will be negative. So actually, I'm going to admit this. I forgot about this solution when I did this question. Yeah, learn from that. Like you got to read the question carefully as well. Just I'm in the habit of just always finding like positive integers, but this is one as well. So just to finish, going to write these out. It's going to be 7 apples. Actually, why am I starting with 7? 0 apples and 14 pears. or 7 apples, 9 pears, or finally 14 apples and 4 pears? Okay, good question. Like it a lot. Hope you did as well.